Hi, Calculus 3 students. This is the second part of the end of section exercise of calculus with parametric curves. So in part A, we've seen the x and y intercepts of that curve. In this part, part 2 or part B if you wish, we're going to find the first and the second derivative of y with respect to x. Okay, so without giving a full reminder, let's begin with the first derivative. So the first derivative, dy over dx, okay? So with the chain rule, it's easy to prove that this is dy over dt over dx over dt, which is more simply y prime of t divided by x prime of t. So from there, easy breezy, you just do the derivative of y in terms of t. So that's going to give you 6t minus 3t squared. And you divide by the derivative of x in terms of t. So that's 2t plus 2. Okay. Now, the question is asking to simplify your answer. So you always want to try to take factors out. And if there's a common factor, you cancel it. But here there's not much you can do. Like 3 is a common factor. T is also a common factor, so let's take it out. So what we have is 2 minus t. All right, here. And that will be useful for the next part when we look for horizontal and vertical tangent lines. Here, we can factor out 2. So 2 times t plus 1. There you go. So this is the first derivative, and that's the best we can do. Now for the second derivative, okay, so we're going to do like the second derivative of y with respect to x. So again with the chain rule, it's not very hard to prove that this is d over dt of dy over dx. Okay, wrong letter here. This is a t. So it's the derivative with respect to t of dy over dx over dx over dt. Okay, so you can prove this with the chain rule. Now, okay, what does it mean? What it means is that we take the derivative we have right over here. So what I'm going to say is, like, we have our 3t, or actually, let's take this one here because it's simpler to do. So 6t minus 3t squared over 2t plus 2. We take the derivative of this with respect to t, but we divide by the derivative of x with respect to t. So in other words, that's going to be 2t plus 2. So here we go. We have divided by 2t plus 2. Okay. So as you can see, this is going to be a quotient rule. So it's best if we do the 1 over. So 1 over 2t plus 2. Okay. Then we do the quotient rule with this guy over here. So the derivative of the top is going to be, let's actually put a bracket. The derivative of the top will be 6 minus 6t times the bottom, which is 2t plus 2, minus the top, 6t minus 3t squared, times the derivative of the bottom, which is simply 2. And all of this is being divided by 2t plus 2 squared. Okay, now what we have to do is to simplify this mess. All right, so okay, first of all, notice that this is the same as this. So we can have here at the front 1 over 2t plus 2 to the power of 3, but we're going to simplify this even further. Let's focus on the bracket here. Let's focus on what's here. So, okay, let's try to factor everything they have in common. So the 6 is a common factor, and the 2 is also a common factor. So we can factor out 12. This will be 1 minus t, and this will be t plus 1, but I will rewrite it as 1 plus t, just as a suggestion. Whereas here, you can take out a 3. So it will pair up with the 2, so that will be 6. So minus 6. And then what we have is 2t minus t squared. Okay, now the reason we do this is basically because we want to see what can we factor entirely out to simplify the calculation, and what do we have to expand. So here, as you can see, if you look at the 12 and the 6, they have a common factor of 6. So, and here, let's also work with this denominator. We can actually take out 2 to the power of 3 in order to have t plus 1 to the power of 3 at the bottom. Now here, what's happening? We have, so this is going to be 1 minus t squared, but there's a 2 in front because we could only factor out a 6. So let's actually put out the 6 here. And then what we have is 2 minus 2t squared. And here the 6 has been factored out, but we need to distribute the minus. So we're going to have minus 2t plus t squared. Okay. We're almost done here. So we have here 6 over 8. 6 over 8 is the same as 3 over 4. So we have 3 over 4. Now this, let's hope that we can cancel this somehow with this, but I don't have many hopes. We can quickly see that this won't work. So let's put the t plus 1 to the power of 3. Now this, the 6 is canceled out, it's a 3. And then we have negative 2t squared plus t squared. So in brackets we have negative t squared. Then we have minus 2t plus 2, like this. Okay, and if you see what's coming up, we will eventually determine the concavity of this curve, which means that we need to factor out the negative, okay, because we will eventually complete the square of the top. So let's just finish by saying it's going to be negative 3 t squared plus 2t minus 2. Okay, all of this divided by 4 times t plus 1 to the power of 3. So this is our first derivative. Let's frame it. And the second derivative is right here. I hope it was helpful. In the next video, we're going to find the horizontal vertical tangent line, but we also will determine the intervals of concavity. Like that will help in sketching the curve. See you there.